All right, this is page 2 from chapter 10, section 8, finding the conditional probabilities from a table. All right, the FBI reports statistics in the following table for homicides in 2014. The probability of a homicide being perpetrated with a gun, let's see, gun, so any type of gun, unknown firearm, so that is these four added together. It's a handgun or a rifle or a shotgun or a firearm. So remember, ors, we're adding them together. These are frequencies. This is the total frequency at the bottom. Remember this kind of table you've seen before. Sum of all the frequencies. We get this number on the top, and then what we need for a probability is the total underneath. Okay, divide it and you'll get your decimal. Probability by a shotgun, given it was a gun. So givens, remember, have different denominators on the bottom. Up here, we actually added up all of the types of guns, frequency-wise, okay, and got this 1824. So that will be our denominator. So given that it was a gun, shotgun individually, though, is 262. Okay. Let's see. By a shotgun, given some type of weapon. Well, let's see. Types of weapon. These are all weapons. These are all weapons. So I'm guessing all of these added up. So that means we didn't use the hand or feet. That was not a weapon. So given it was some sort of weapon, so I took the total number and subtracted just the hands and feet out of there to get all types of weapons and use that as a denominator because this is a given. Remember, our denominator is different than the total of everything. So we put this number here, and then I went back and looked at shotgun again by itself, 262. Okay. Find the probability that 2 random murders were both committed by a handgun. 2. So the probability of a handgun up here over the total is here, and that would be for the first one. So 5562 divided by 11961. That is the probability the first random non-related murder was committed by a handgun. The second one, remember, we're multiplying. It has to be the probability of this and the first one and the second one. So we're going to be multiplying it by the same thing. Okay, so that's the same as this being squared. So be careful how you're doing that. Raise it to the second power, or just multiply it, or make the division once and then multiply by that same number or square that same number and get this. Okay. So 3 unrelated murders, probability that all 3 were committed by a gun of some type. A gun of some type we had, given they're a gun, so this number here was a gun of some type out of all of them. And because there are 3 different unrelated murders, then you're multiplying this 3 times or raising it to the third power, and you will get that. Okay. The probability if there were 2 random and neither involved a gun. I actually don't want to keep this down here. The probability there were 2 random murders and neither involved a gun. So these, let's see, where's our gun number? Our gun number was here, type of gun. So that's the 8124 for neither type of gun. And if I subtract that from the total, I will get 3836. 7, which is the number of murders that occurred that wasn't a gun wasn't used. Okay, so that means these three. All right, so this was the 8124. This is whatever 11,000 minus these gives you these. Okay, so that gives you that. That's how many out of all of them. And how many murders? There were 2 murders, so you can raise that to the second power, and that should come out to here. Okay, so it's about a 10% chance. By a rifle or a shotgun, rifle was, let's see, rifle was 248 out of all of them. Remember, ors involved the total number on the bottom, and we're adding shotgun. And it can't be a rifle and a shotgun at the same time. It doesn't say or a gun, so it's not a, I don't have to subtract anything because these are mutually exclusive. This comes out to 510, which is approximately 0.0426. So that one's around 4% rifle or a shotgun. Not the very common, obviously. Handgun's the biggest one. All right, so at the bottom here, the last part, probabilities of large samples, percentage data. According to January 2016 report by MarketWatch, 70% of college graduates will leave college with some student debt. Then the empirical probability of any one student doing so is 0.7. Okay, so they observed, they asked questions, they did a survey, whatever they did to find this number is an empirical probability, okay, versus a theoretical. So that's 0.7. But if you ask 4 graduating seniors who are randomly chosen if they have student debt, what is the probability that all 4 will have debt? Well, the probability of the first, 0.7, times the probability of the second, times the probability of the third, times the probability of the fourth, assuming they all have debt. So that's the same as 0.7 raised to the 4th power because they are independent events. Okay, is about 24%. The probability that none of them have debt, so that is 1 minus that, or 0.3 raised to the 4th power, you get this. Okay, that is all we will be covering. We could figure out how many 1, 2, or 3 would have any debt, but it's a little complicated, and it is skipped in the textbook, so I skipped it in the homework. Okay, so all you need to know is all 4 and none. I mean, it's not that hard. It's just there isn't any examples in the book, so I didn't want to throw anything extra in there. But for one, think about it. This would be 4 times 0.7 for the first one having debt. But then the other ones can't have any debts. So it'd be something like that. Okay. And then 2 is 2.7s and 2.3s. And then 3 would be it. So anyway, don't need to know that. So I went through the homework to make sure that's the only questions you have. So national study of patients who were overweight found that 56% also have elevated blood pressure. If 2 overweight patients are selected, find the probability that they have high blood pressure or neither has. So we have 2 patients, right? They're going to be multiplied together. 56% is the same as 0.56. We have 2 people, so you can square it or just multiply it by itself for the probability that 2 people have high blood pressure. And then neither have 1 minus 0.56 equals 0.44. So the probability that neither has is 0.1936. Okay. Salesperson, 20% chance of selling a computer when they help a person. She helped 4 people. What is the probability of selling a computer to all 4 customers? If there's only a 20% chance of selling them to one person, there's probably not a high probability that they're going to be able to sell one to all 4 people. In fact, this comes out to less than 1% having a sale with all 4 people. If you're a salesperson and you're this is being tracked, just if you don't sell so many things or whatever, people need this information to see how well their employees are selling. Okay, probability of selling to 0 customers. 1 minus 0.2 is 0.8. Certainly more likely that you will have no takers for a computer. It comes out to about 41% of no sales for any of the 4. So that still leaves you like 60 or 59% chance of selling to at least one person. Okay.